Welcome everybody. Thanks for coming out to the Seattle Revit User Group today. My name is Rob Bendix, SeaRUG President. I know I just found out, I didn't realize the 520 was closed for a little while for some boat crossing. So hopefully some of our east side companions will get over here. I didn't even realize because I took I-90 across today, so completely bypassed it. But see, someone else accidentally got stuck in it, but you made it. You were prepared, you left early, and you went around. You went 90, of course. So, yeah, otherwise we'd probably just be walking in. So I guess let's get right into it. Seattle Revit User Group, we're definitely proud to be a completely Revit-centric group that definitely prides ourselves in providing platforms, trainings, initiatives, sessions that work with all disciplines collaboratively, and not necessarily niche ourselves in any particular flavor of Revit. So we know that Revit BIM practices is definitely a AEC and kind of a very, very collaborative effort. So we definitely want to make sure that we speak to all of our disciplines, all of our groups, and making sure we're all learning what each other's doing, because quite honestly, it's just going to make us all that much more productive and better at what we do. Anybody here for their first meeting? All right, cool. Well, welcome. Hopefully we'll see a lot more of you in the future. MEP users, obviously per the topic, we got to throw it out there. MEP users, all right. Excellent. Always a good crowd. I will say that for the survey last year that we did at the end of the year, we definitely got a lot of write-in responses for more MEP content, and we listened. So I mean, we had this one. We had earlier one, kind of dive into some MEP content. So definitely looking forward to this one. I got a little preview of it, so I'm definitely excited to see what comes out of this. Revit architecture structure users that maybe just a little more interested in knowing what MEP disciplines could be delivering or can deliver. Yeah, that's me, definitely, for sure. It's always good that you take the time to come out and see what other groups are doing, because that's, if anything, we really like to push that, because the more you know about what each other's doing, I just think the better we're all going to be for it. I'd like to, of course, recognize our sponsorship partners, our executive partners this year for 2012, PPI, Imaginet, and ID8. Our premier partners that we have this year, Corey Group, ARC, and ABC Imaging, who just so happens to be our host sponsor for this month. So thank you to them. Our associate partners, of course, firms, groups in the areas, GLY Construction, Mulvaney G2, Leidig Construction, PCS Structural Solutions, Slater Partner Architects, BN Builders, and FSI Consulting Engineers, who just so happen to be giving our presentation today. So we'll hear more from them in just a little bit. And if you are interested in associate partners, sponsorships, you can go to SeaRUG.org, look under our sponsorship link, or you can email sponsors@SeaRUG.org. Or if you just want to talk to me more about it after the meeting today, just come down and find me. Some news items. I usually just kind of put this one out there every time, especially for new users, or sometimes people just seem to forget that we post up all of our meetings. We are recording this one as well, so within a couple of weeks you'll be able to go onto our SeaRUG site, check it out, maybe show it to some others, so you don't have to try to repeat all the good information that you hear. You can play it like at a lunch and learn, or just view it another time to get refreshed on the presentation. A couple other things, CAD Americas. This is the CAD Camp. They rebranded it, I guess. It was kind of interesting. It's like the same website, it's just rebranded with a different name. CAD Americas, so they're actually kicking off the 2012 season in Seattle at the Renton Technical College on September 6th. There's going to be a lot of 2013 product focus on all this, for obvious reasons. It's been out for a little while now. Sign up before August 15th, and it's a $150, $195 after that, so our students and faculty members is $95. It is a one-day session. It's like a full cram-packed day, so if you've ever been to something like Autodesk University, where you just go from like 8, 9 in the morning till about 5 in the evening, we're just running a bunch of sessions. That's basically what it is. A couple of notable instructors that'll be there. Robert Green, CAD management guru. I think all of us, or most of us, probably have heard of Robert Green before. And if you haven't, look him up, because if you're going to do any sort of CAD or BIM management, he's definitely one you want to read. As well as Todd Stevens, a well-known Revit expert. So they'll be there along with a whole bunch of other people. So you can go to cadamericas.com and check it out for more information. And of course, Autodesk University 2012 is right around the corner. I'll pretty much keep reminding you of this. November 28th, 29th, 27th, 28th, and 29th at the Mandalay Bay. Membership for AU Online members begins August 28th. So if you're signed up, it's free. Just go sign up, and you get a chance to sign up about a week prior to normal registration, which is great, because if you're one of the people like myself that likes to get into labs, you want to jump in right away, because they get filled up first. So if you're able to get your paperwork rolling right now to get signed up, or to get your approvals in place, you might want to think about doing that now. Another note that came up that I got reminded of by Alex Lepesca, if you know that name. He's the Puget Sound Autodesk User Group head, and they do their meetings down at Renton Technical College every month. And I was reading his last update and was like, oh, I totally forgot about these. So wanted to share it out. Who here is either professional or associate certified in Revit? Oh, there needs to be more hands than that. Come on, guys. Well, thank you. So certification is actually, it's a pretty neat thing. It's simple. It's actually not too complicated. If you consider yourself a fairly good Revit user, you probably won't be too challenged by it. And for someone like myself, as a design technology manager, BIM managers out there that hire or interview or want to see what people's just basic knowledge is, having that certification is a nice feather in your cap. Now, granted, it's not your engineering degree, it's not your architectural license, exam license, but quite honestly, it is nice when you can be able to present that and say, hey, yeah, I'm up to speed. I know what's going on with Revit 2012 and 13, etc., and I'm comfortable working in it. It really kind of helps kind of cut through the muck a little bit, and at least I know at a baseline of where you're at, or where yourself is at. So it's definitely a nice little token that I think most users should have in their portfolio. So anyways, they're doing this program. It's basically on one day, and you can register for exams online. Actually, they got a special deal going. You can win an iPad too if you register to do this. $25 for the associate or the professional. Now, if you've done this before, you've heard about it. If you already are an associate professional in the previous version, to keep up, all you have to do is the professional one each year, so you don't have to do both. But when you very first get it, yeah, you'll have to do your associate and then your professional. The associate test is a multiple choice, takes about an hour, and I think they give you 90 minutes for the professional one, and that's a hands-on test where they throw these questions out, you got to go through them, and do the exercise to find the resulting answer. So, like I said, if you feel pretty comfortable in Revit and the concepts, you should have no problem with it. And they are normally 125 for each exam. So $25 for either one or the other, or if you want to do both, you can do it for 25 bucks. The local participating centers in Seattle are Ideate and Imagine It. PPI does it as well. But for some reason I didn't see you on the certification, on the code list. So maybe they will be within the next couple of days. I'm sure Brian will go back and find that out. So anyways, it's going to be on, did I put the date in there? August 10th. Oh no, I didn't put the date in there. It's going to be on August 10th. There's another one coming up on October 12th. So I apologize for that. It looks like a little slip in the PowerPoint. So yes, August 10th, sign up for it. You're pretty much going to just probably track people in, let them take their exams in one day. So go check it out. Or, and you can go to atcgilmoreglobal.com, and right there on that main page, it gives you all this information. And then if you want to find out more about the certification, the exams, research prep materials, etc., you can go to autodesk.com/certification, and there's a whole bunch of information there about what you need to know, what's covered in the exams, etc. And then also, if you're planning on going to AU this year, every year at AU they always offer the exams for free, because you are, paying to go down there. It's just kind of an added-in item. But be careful because the lines get long, so go in early. Plan accordingly. I made that mistake last year. I stood in line for about an hour to get in. So, but they do pretty much hold it the whole week. Okay. Autodesk Labs, I always like to look back on this. It's a great site for good information, especially if you're the type like me that just kind of like to know what's coming up, know what's out there, know what's in the pipeline. Autodesk Labs is almost like a test bed for research of technology that usually ends up into products or even standalone products at times. So getting involved and just kind of perusing the Autodesk Labs site is actually a great way to get an idea of what's coming down the pipe. Now there's a new product out there, which is not really new. Autodesk Fabrication, Fab MEP. That's absolutely fab. Sorry. I bet you I wasn't the first one to do that. Anyways, see, this was CAD Duct, right? Prior? Is that right? Okay. So, any CAD Duct users in here? Do design build stuff? Okay. So then you jumped on you checked out this new version? Not yet? Okay. So anyways, what they did is they actually developed an import for Revit MEP, because right now you can actually export the files and kind of jump back and forth between them. But it looks like they're developing a little plugin that actually allows you to open and export directly between MEP and Fab MEP. So if you're using that, it might be something worth checking out. eTransmit for Revit 2012 has graduated, so if you're a subscription member, you should be able to see that in your downloads page. Why the 13 version came out before 12, I'm not really sure, but sometimes I don't try to question what they're doing. I just go with it. It's like, okay, that's what you're doing now. It's included in Revit 13. Oh, that's right. Okay. All right. So now moving on to our sponsor recognition. Definitely the sponsors that I mentioned earlier, they're a big part of what we do here. Quite honestly, it's pretty simple. Without their support and what we're doing, we don't have these meetings, we don't have lunches, we don't have these great presentations that get put on. So we definitely appreciate them, coming to the table and helping us out. And this month is ABC Imaging, and James Pike and Wojtek Podolski. Got it. And now ABC has actually been a sponsor of ours pretty much from day one. They were here our first year, and have, if I'm not mistaken, you've sponsored us each year. So we definitely appreciate their support in what we do here. So I'd like to bring them up and let them talk a little bit about what's going on with ABC. Thank you.
Good afternoon or good morning, everybody. I wanted to talk to you a little bit about our online plan room, and this is a great opportunity to do that. It's a collaborative tool that we've actually made in-house. We have programs that work for ABC Imaging. So I'm going to talk a bit about, it's called Blueprint Online Next Generation. If I can get the computer to work. Oh, okay.
Here's the arrow key.
So it's basically starts as an FTP replacement. It becomes a tool for integrated project delivery and communications. The overview, BPO it's multi-currency because you can actually order prints. You can actually use it in different currencies. It has languages, English, Chinese, Russian, Arabic, and obviously we're working on other languages. We work with all the disciplines, architects, engineers, contractors, and then it's available on desktop, laptop, obviously tablet and your mobile. And why should you use BPO-ONG? It basically supports a project lifecycle from the cradle to the grave, property acquisition, design, construction, and facilities management. It's transaction-based, custom permissions to each folder per user, audit trail for user activity. It's basically very helpful for keeping everything in one place. And a lot of projects end up in lawsuits, and this gives you the ability to have everything at hand. It's collaboration, streamlined communications, collaboration amongst the entire project team. It's integration, synchronization with existing tools. We can sync with Dell Tech, Nuforma, SAP, Oracle, Autodesk, Exchange, Active Directory, SharePoint, and Microsoft Office. It's cloud-based, scalable, ease of entry implementation. There's no servers, no cost to implement, no hardware, and no maintenance. Security, HTTPS, permission-based, industry-leading hosted secure environment with data encryption. It provides clients ROI, project billing, reduces need for file storage, reduces travel costs, reduces paper, expedites workflow, drawing approvals, file searches. How will ABC Imaging implement BPO-ONG? It's basically, we design a plan, we come to your office, we support the client, we configure features, we discover client needs, assess user experience, deploy applications, and review with the clients. We meet client users, learn clients' requirements, and we select most problematic project. We then go and develop project delivery requirements within system workflows, and then we set up a company administrators, register all project team members, customize client site. We put the logo, reports, transmittals, and stamps. Perform on-site. We develop a parallel with existing client systems. We set up project in BPO-ONG. We review the project tree with the client. We revise as needed. We migrate data from existing projects. We build complete history with versioning, synchronize, and existing tools. Ensure a smooth implementation. ABC and expect on-site ready to train users, troubleshoot applications. Monitor use with transactions, logs, evaluate workflows, survey client users when possible. Meet periodically with client project team managers. We use meeting agenda to resolve application issues, schedule corrective action, and then we implement addendums. What can our project team do with BPO-ONG? It's full-featured project document management. It has a calendar, it's a dashboard, it has announcements, it has address book, RSS feeds. There's all sorts of different reports that you can actually, there's feedbacks, there's permissions, and there's templates. And that basically completes BPO-ONG. I want to talk a little bit about, we have some handouts here for people that if they're leaving that they're interested in looking at BPO-ONG. We're actually doing free demos. We can come to sites and come and do a demonstration. We're going to leave some business cards on the side. But at the moment, we've got multiple projects all over the country on BPO-ONG, and they're really enjoying it. So if there's anyone is more interested in talking about it, we'll be happy to talk to you after the meeting or later next week somewhere. Thanks very much. I'm going to pass you back to Rob.
Thanks a lot, James. Really appreciate it. Yeah, they might have to swing out early, so definitely come by and check out some of the stuff. I've seen the demos. Pretty impressive and dynamic product, so it does a lot. It does quite a bit. Okay, so for our feature presentation, I'm going to read through a little intro here for you. Hopefully it doesn't take too long. Eat too much into their time. But for our main presentation, so Brandon Crane and Kevin Chadwick from FSI Consulting Engineers are here. Both of these gentlemen are professional engineers, hold bachelor degrees in mechanical engineering. Brandon from Washington State University and Kevin from Montana State. They both natively design in Revit, which is quite interesting. That's actually fantastic. Between them, they have a wide variety of experience covering commercial, industrial, educational, mixed-use, multifamily, and institutional markets. Since being introduced to the program in 2007, they have strived to use the program as it was intended. So as a result, they learned how to effectively employ BIM on projects without sacrificing the quality of the construction documents or the integrity of the models. So I guess without further ado, here's Brandon and Kevin to talk about BIM in existing buildings. Right.
You got the... All right. Well, thanks. Yeah, as Rob mentioned, I'm Kevin. Okay, and now it's Brennan. We're with FSI Consulting Engineers. Thanks to everybody for coming out today. So I'm going to give a quick roadmap of where we're going to go today, just so you can kind of follow what's going on. I'm just going to do a quick introduction, and then we'll get to the meat of the presentation, why we're all here, talk about Revit MEP and what we've done with it within existing buildings. So, and then we're going to talk a little bit at the end about some new technologies, some CFD airflow analysis, and talk a little bit about point clouds. So, let's see. So FSI, we're a full-service mechanical firm. We've been in the Pioneer Square area for about 25 years. And you can see a full list of stuff we do here. And, of course, BIM modeling is up there. We're here to talk about that. So project sectors, we have our hands in a lot of different markets. Renovation is a lot of the work we do. And so that's why we're going to be talking about existing buildings and how we've utilized it in Revit. So, but you can see civic, education, commercial, got our hands a little bit in wineries, and then industrial and aerospace. And a couple of our examples today actually are the industrial aerospace focus. So there's some pretty neat stuff that you guys are going to see on here. So at FSI, we spend a lot of time developing and really kind of nurturing our corporate culture. And a couple things I want to point out here is what Revit has really helped us do is really become even more proactive, get involved even earlier, and we always have, but it's just a tool, and we're going to show a couple of examples of how we've been able to do that. And as you all know, the communication is just so much easier with Revit. You can collaborate back and forth so much easier, and we'll highlight a few things on a couple of the examples we got coming up. So, because how we've worked on our company culture, and Revit has really helped us work the way we want to work. There's a couple things on here I'm going to highlight, but the one that I'm going to just point out right now is, so it's an interesting thing about FSI as a mechanical firm, we actually prime about half of our projects, which is a bit unique, but it gives us a good insight on what it's like to have subs or be a sub, and it just really highlights our abilities to meet schedules, meet deadlines, and just keep that communication going. You actually see we got a pretty good quote from a Seattle architect on a project that's in construction right now that we're awesome. We actually meet our deadlines and get our submittals in on time, so it's a good compliment to us. And let's see here. So I'm going to give a quick introduction about BIM. Like Rob mentioned when he was up here, we've been in it since about 2007. We actually just modeled a quick room in a brand new school up in Ferndale. We didn't include it in our construction documents or anything, but it was just really we wanted to see if we could fit everything in this small mechanical room. It was definitely at that time that we as an office realized that, okay, this is where the industry is going to go, and we knew it was going to be important for us to kind of grab the bull by the horns and go with it, and so we really have. I'm going to introduce Brennan and get him up here and talk about a few things, and then I'll bounce back up here after he's done.
There we go. Okay. All right, we can hear me now, right? Laser pointer. Ooh. All right. Thanks, Kevin. Like Kevin said, we do a lot of renovation work, and that's kind of the subject of this presentation, is how we can use Revit in existing buildings effectively and still make money. Existing buildings come with interesting problems. You're never going to find two buildings alike. They typically have complex systems inside of them, complex issues. Some stuff needs to be replaced, some stuff doesn't. Varying locations where the work is going to be done. It's not just everything is new. Commonly, they're poorly documented. When you ask for electronic backgrounds, you could get everything from CAD drawings that are complete, but you still need to go verify if anything on the CAD drawings are actually in real life in the building. Or you could be missing like 3 TIFF files. You know, worst case scenario, best case scenario. They're often very aged and broken. If we were there, chances are, well, not if we were there, if we are there, something needs to be fixed. So that came out really bad, sorry about that. Anyway, some challenges that existing buildings come up with that's unique from new construction is they're occupied. You need to make sure that the contractor can get into the building, do the work, and get out without disturbing all the people inside of the building. You need to make sure that you disclose what, the arena that the contractor gets to play in when you submit the documents so they can be properly bid. Making sure that routing, as you described on the drawings, is actually possible. And describing to the contractor where those points of connection are. It's very important so that the contractor doesn't waste a lot of time and spend much of the owner's money trying to find those, specific little points of existing water piping or whatever that you alluded to on the drawings. Verifying the constructability is really important. Can the new piece of mechanical equipment slide through the door? Simple stuff like that. All this relies on knowledge of the existing building, whether the dimensions as shown on the drawings are actually right. You got to have a good model before you can start working on all this stuff. And a lot of times you aren't given a good model, or you definitely aren't given a BIM model when you start a project. So what we've done is develop BIM models where we didn't have one before with existing buildings. So when this job got started, my boss was on vacation. We were trying to decide whether we should do a typical waterline replacement project in Revit or in AutoCAD like we typically do. And it works just fine to do it in AutoCAD because pipes are small and you can pretty much lace them through wherever you want it. Well, we wanted to try to use Revit on this project, and we're glad that we did. A little background on the job. The building is in Auburn. It's about 100,000 square feet. The building was originally built in like the late 50s, and then in the late 60s they added like 60,000 square feet to it. That ends up being everything that's on that side of that line there. It's a brand new rectangular section of building. This is going to be a publicly bid project. This is it's an occupied building. It's going to require some really complex phasing plans. And we also needed to make sure that everything was nice and tight. That the points of connection were well documented, that the phasing was well documented, that the contractor layout area, all this stuff. We also didn't have any electronic backgrounds, or electronic CAD backgrounds, I should clarify that one. So we would have had to start with nothing regardless of what platform we had. So what we did is we took the CAD architectural backgrounds that we were given, and we linked them into Revit, and we traced them. And we developed a BIM model to use as our background in our waterline replacement project. After we had this, this model of the building, in BIM, we sat down in our office and we routed some pipe through the building, and we used the placeholder lines to just give us an idea of, you know, the places where we like to route pipe, and then we'd go out and we'd see if that would actually work. We took the model as proposed out to the field. We got a laptop with a standalone license, and we just checked everything. And as we were checking it, we moved pipe. And we made sure that it included elevations and the system types and all sorts of stuff, so that we didn't have to spend a bunch of time in the field, you know, annotating everything and making sure that the heights were noted on the drawings. So it sped things up. After we had a good idea where everything was going to go, we took it back to the office and detailed it. And that basically became our 60% set at a 30% level. So when we linked the existing CAD background in, the way that we did this is we created a central file, so we had work sharing on. We created a work set that was specifically for the CAD background. We didn't want the CAD background to show up in pretty much any other view except for this existing, like, as-built-in view. So when we linked in the CAD, we made sure we had our active work set being that 2D background. And when we linked it in, that's what work set the linked file gets applied to. And then we traced everything. The amount of time that we spent monkeying with the tracing of this deal was about 4 hours total. We modeled the floors, the walls, the doors, and the roof, and some ceilings in some areas. That's where we stopped. Because we linked stuff linked the linked CAD file into a work set, we were able to control whether it would show up in various views very easily and very quickly. And throughout the project, just by playing with the work set global visibility setting, worked really well. And we could use the automated filter controls. If we didn't want to see the fancy text, the annotations, and what types of wall types or dimensions of the existing CAD background or whatever, we could turn off those layers, and that was really handy as well. These features or these controls can be applied to a filter, and you can apply the view filter to different views, and then you can propagate a bunch of these new views, and they all look great. When we're editing stuff in the field, like I said, we just haul the laptop around, and there's me sitting over my tiny laptop, and for whatever reason, all the countertops are not as high as I'd like. So anyway, we had a lot of fun doing it. This has been another guy from our office and me standing in front of a giant fan that's in the building. But yeah, we did a lot of as-builting. If I took some action photos of actually doing what we were doing, it'd look about the same. But
so
these are more fun.
I just want to interrupt for a second. When we talk about as-builting,
thank you. Yeah.
We're really referring to modeling the existing building. I know a lot of as-builting is talking about that's what we do after construction. We go in and as-built a building. We just throw it in there as a word, but it's really us going in and model the existing features, walls, equipment of the building. So I just want to make sure that we're not confusing that for
thanks,
anybody.
Kevin.
So yeah,
we throw it around too softly. So, like I said, what we didn't do is we didn't spend a bunch of time detailing all of the architectural bits and features of the building. It really wasn't necessary. We're issuing mechanical plans and, the door types and all that stuff really isn't that important for what we were doing. We didn't bother getting all the penetrations through the walls as we needed because the pipes go through just as fine, and that's only going to matter if, our spec covers fire protection penetration, so we're good to go. We didn't model the existing systems. Like I said, this project had a bunch of stuff above the ceiling. Multiple tenant improvement projects have clogged the ceiling of this building. We didn't model the stuff that was put in during those tenant improvement projects. We found spaces in the building that we knew we could route pipe through easily and with confidence. Because we routed the pipe in those places, we didn't feel the need to show the contractor ahead of time what they would be coming across because we knew there was a nice big open spot. We didn't bother doing a lot of the ceilings because once again, they weren't going to show up in our plans. Some benefits that we found when we did this, through using Revit on this project, was we were able to speed up production considerably and increase the amount of clarity in the drawings by including pictures. I didn't include an image of what this thing is actually pointing out, but in that location it says, location of existing shutoff valves. I found a shutoff valve the contractor needs to know about in order to maintain this phasing plan. So I took a picture of the valve and I put it in my project. I put it onto a detail in a separate sheet, and then I put a little detail bubble around it, that one, pointing to that picture. So I can tell a contractor, this is a shutoff valve right there, and this is what it looks like. That's something that would typically take a lot more time in CAD than we would expect to spend in Revit, and that's one thing that's nice. Something else was we did elevations for patch and repair, and because we modeled the whole building, because we had a bunch of pipes starting from wherever the water was coming from in the main all the way out to each fixture, we could, and we had a BIM model of the building, we could cut sections or elevations for these different walls. And we could put those onto sheets. We could name our sheets whatever we wanted. In this case, I named those sheets A, and we exported that sheet with all those views that I created into CAD and gave them to our architect so they could use them as our background. So that worked really well, saved us time, and it saved them time. This is a picture of that patch repair elevation sheet. And they ended up prettying this up quite a bit. I was just showing them kind of where the patches need to be. They added a bunch of notes on top of them. Because we had everything modeled from, point of water coming into the building, the water main all the way out to every fixture, we could just go ahead and make enlarged plans, whatever scale we needed to have in order to pump out a clear set. In this case, this is a 3/8 inch by equals 1 foot scale set, and it's a little odd scale, but when we tried quarter scale, it didn't look good, so we changed the button and it, bam, changed everything. So that one step of moving everything from quarter scale to 3/8 scale could have taken a lot of time, but since we're using this, it didn't. Saved us time, speeded up production, increased clarity. Something else that we did is we were able to include 3D pictures of our water heater or complex areas in our project, just so we can show the owner what this is going to look like when it's all said and done. A.O. Smith was nice enough to have produced some Revit models of their water heaters, and we could bring those in. We had to tweak all the shared parameter features of the water inlet, water outlet, electricity input, weights, that type of stuff, so that it would talk nice with all the rest of our model. But once you figure it out and you get it set up, you've got an element that works nicely with everything else in your model.
What kind of feedback do you get? Is that built more for the owner or to the contractor?
That was for us. Yeah, we did that. We played with the shared parameters stuff because we wanted to make sure that we could include everything on our schedules.
Oh, sorry, I meant the visuals.
The visuals for the contractor, visuals for the owner.
Any feedback from contractors on
We've had,
appreciation of that?
we'll actually talk about that later, and we've had some really good feedback from our, not only just our owners, but also the contractors about our 3D images that we included in our sets. Like I said, we put the time into making sure that these things were actually, had the shared parameters set up the right way so that we could put all of the, they're schedulable, and these things update automatically, and they talk nice with everybody else. If you set it up properly, you can export your model or give it to your subs or your architect or your structural when you're sharing a model, and they can pick up your water heater and they can find out how much it weighs. That weight will talk to their model as well. But you have to have it all set up right, and everybody has to be talking apples to apples. But anyway, so in summary, this GSA water line replacement project, we found that the benefits of using Revit were we had a lot of confidence in our routing through the building. We're able to provide architectural elevations to our architect and help them meet their budget by not having to trace or recreate something that we could just print pretty easily. We could add lots more sheets without significant cost. We also were able to use the takeoff feature of Revit, we could create a schedule that we could ask how many total, how many lengths of half-inch pipe, for instance, are there in the project? How many half-inch fittings are there? And we could include that information or cost estimates. And we were able to include a lot of reference images in our plans, among other things that we wouldn't have otherwise been able to or had budget to do in CAD. So I'm going to hand it off to Kevin here. He's going to talk a little bit about another project that we did in Revit. Thank you, Kevin.
Yep. Thanks. So we kind of joke about this in our office that for a presentation like this is a local airplane manufacturer that we do a lot of work with. Now we can say Boeing, but so I love this project because this is really where we got to see what Revit could do and we got to push it, and we learned a lot on this project. So which one's the pointer, the center?
The center one, yeah.
Okay. So this building, the renovations we did in this project was roughly about 87,000 square feet, and it was in 2 different buildings up in Everett. So just quick background here. So FSI was hired to come in and ventilate these tools, and what I'm going to call as a tool is what they actually see like the plane section sitting in. And so painters have to go in and prime paint, do any sort of little fixes, but they needed enough ventilation so they could really do their work, and a lot of it had to do with the priming and the painting processes. They wear respirators and everything, but Boeing still wanted to meet all the requirements even if they weren't fully suited up and on respirators. So we got hired in and to put in the ventilation. So all this stuff that you see here, the structure, the stairs, everything, that's all existing. It was built, some 20 years ago, some 30 years ago, just depending on what building we were in. So we decided in our office, because, if Boeing's not building airplanes, they're not making money, so they can't afford to have downtime during construction or change orders or anything going on during construction that says, oh, well, you guys are routing a duct here, but we can't put it here. So we decided, and we just made the choice in our office that we're going to as-built every existing structure that we touched on these 13 different planes. So we did 13 of these stations. So as you can see, this is actually a front end of a 767. And so the way that Boeing builds a plane is they roughly break them up into thirds. You got a third of each plane, and they just crane them around different parts of the facility to the different manufacturing processes. So we had to do this in 13 different stations, and we had to be fully confident that when we routed our ductwork and placed equipment. So you can see here, this is roughly like a 5-foot by 8-foot air handling unit, and there's actually one buried back in here too that you can't see. And modeling this in Revit just allowed us to be completely certain that when we put equipment, duct, whatever we were putting in there, that when it got on site and they started building it, that it fit. And so, what I did, like I mentioned, we did 13. It was roughly 13 separate projects. So we had 26 submittal packages, 13 for our contract, 13 for the client, and with Revit, we were able just to do so much more with the end users than we typically can. So during like a 60% design, and I'll touch on this a little bit more, but we always ask for review comments or give us your comments, feedback on what we're currently showing in our design. But in Revit, because it's in 3D, and that's the way a lot of the users, painters, whoever it is out there, owners, that's the way they view everything, their feedback and their comments are way more valuable because we can make the change when you might not be able to see that on a 2D drawing. So what we used is just your standard tape measure and an old-fashioned disto.
That was old too.
Yeah, it's pretty old. So, and we did the same thing. Specifically on this one that we did here, Brendan and I were out there. He had his laptop, little rolling table, and we used the tape and the disto, and we just built the tools. And so the result of the as-builting is we had a full model of whatever building we were in and of the locations that we were working in.
Within an inch.
Yeah, and we got a couple pretty good quotes and things that we've got on another project that Brandon's going to highlight here in a minute about, you know, the accuracy that we're able to put this stuff in. But you can see that with Revit, it's so much easier to design, and you can really get the as-built. You know, this is side-by-side picture of what we designed and what they actually installed, and it's very similar to what we designed. And like I said, we needed to make sure we were right on, because like if Boeing has to stop because of, you know, a duct in someone's way, I mean, they're not building a plane, they're losing money, and it's important that we had it right. So with AutoCAD, I mean, the 2D world's a little bit different. We definitely couldn't have got there. We could have got there, but it would have taken more time. You know, once we had our model built and we were sure of our accuracy of everything, the 3D world, that we were able to get what we wanted. So because we had 13 different sets, it was in Revit, as everybody knows, it's so easy just to create more sheets, as Brandon talked about a little bit earlier. And with the 13 different submittal sets, we were able just to really pound those out pretty quick. I mean, we already had everything set up, and it wasn't, you know, a headache to get in there and do it, and a lot less time than it would have taken in the AutoCAD. And, you know, again, the sheets are always current. When we're dealing with 13 different submittals, we had 3 different designers working on this project. And so we had, you know, every week we had 2 or 3 submittals going out, whether it was a 30, 60, 90, or an IFC set. So with Revit, able to keep all the dates and the submittal titles current was really key. Without, you know, we didn't want to have sets that said, you know, 625 of 11 on a 90% set when it was an IFC set. So it was just that piece of Revit where you can keep everything current. Everybody knows that that's a really good, valuable tool of Revit. So this piece here, BIM for communication is what we call it. And let me, there we go. That's what I'm looking for. So as I mentioned a bit earlier, when we have painters and users looking at our 2D drawings, we want comments. It's really tough for them to say. I mean, they're not as versed as we are as reading the 2D drawings. It's just kind of a spider web of information to them. And so what we did, this is just a video that we put together. We actually went up to Boeing in a conference room, hauled our laptop, our projector, and we sat in a room with 10, 20 people at times, and we just, what we called, flew through the model with the right people. And we didn't create a video like this. This is really for the presentation, but we walked through like you can in Revit, and I can't tell you on the 13 projects, I mean, we probably avoided 100 different changes during construction. Nothing major by any means, because I mean, we have a really good understanding of how they use the building there. But I mean, just things where painters would say, hey, we can't put a duct there because I need to stand in this location to paint under here. So I mean, just things like that we would have caught in design. I mean, even though we asked for 60 or 90% review comments, they don't understand how to read the drawings, so we would have never got a comment. But when they see it in the 3D world, it's like, oh, you can't do that. I need to stand right there. So, I mean, that change would have, without the fly-throughs, and without the 3D walkthroughs, that change would have come up in construction. And when we got 13 projects going on at the same time, I mean, if you take 1 or 2 changes that have to happen during constructions on all those projects, it's a lot of time and money wasted, really, and we were able to avoid all of that. And it's pretty evident on the picture where I had the side-by-side. You can see that everything just got installed as the way we designed it. So the benefits, like I said, we're able to really manage the complex design. Like I said, this was 87,000 square feet where we did the renovations. These buildings are huge. If anybody's familiar with the Revit facility or the Everett facility, so working in these big buildings and having a model that was accurate was key. And you know, we were able to, like I said, everything was existing, so we were able to avoid any of those conflicts. I mean, there's spider webs of structure going every which direction to hold those different sections of airplanes. So it gave us a high level of confidence that we could route and place equipment where we needed to place it. And the communication, I mean, that was flat out, outside of using Revit, the key to the success of this project was able to just sit down with the people in the 3D world and say, yeah, it looks good, or no, we just need to move this or that. So the communication piece has just been really valuable in Revit, and as you guys all use it, you understand that. So I'm going to pass it back over to Brandon. He's going to talk about another project that's actually almost done with construction right now, that we designed about a year ago. So
Yeah, we're going to actually go down and commission it tomorrow, right?
we're going to punch it tomorrow.
Punch it tomorrow.
Yeah.
Sorry, wrong word. It's going to be fun. It's really big.
Yeah.
So this is a very opposite corner of the Everett complex, 4037 building. But it's, well, Boeing wanted to paint and seal and do things with their airplanes that with robots now instead of with people. So they installed robot tracks, and they're going to put a robot on there, and it's going to paint airplanes and all sorts of stuff. But they had to modify the existing paint booths that they have so it would fit the robot and the airplane and all the paint booth stuff. There's a little kitchen in the middle. Real complex project. This is not the complex portion of the project. Now look for this type of shape in the next slide, okay?
So this is the first floor you're seeing.
Yeah, this is the first floor.
Yeah.
This is the basement underneath it. There's that same shape, right? Okay. From about here to about here is about as long as a football field. Some of these ducts in here, like that one right there, is 8 foot by 8 foot. And there's 3 of them stacked on top of each other. So it's a 25-foot tall ceiling. There's tons of stuff to avoid. Knowing how complex this basement stuff was going to be and how we had to shuck and jive around a bunch of existing stuff, we couldn't just simply wipe it clean and start over because we wanted to save the client some money. We modeled the whole shoot and match. Everything that was down there, every bit of duct that we thought we were going to be in the way of, or it was going to be in the way of what we wanted to do, we modeled. And once again, we just used a tape measure and the distometer and went down there with me and a cart and my computer and a pair of headphones. I was down there for about a week, and we modeled everything. So what we ended up doing then is took the model and cut it up and took and demoed what we needed to have get out of the way. We created hybrid construction documents. Boeing requires that at the 60% and 90% submittal and 100% that their drawings meet their requirements, i.e. they still have all of the engineering on those documents as they had when you got them and started playing with them. So regardless of whether you touch the area or not, you got to make sure you still show the stuff that you're not touching. We also used our model, which was, we had a lot of confidence in the accuracy of everything that was in there, as a way to facilitate the coordination between us, we were acting as the prime, and all of our subs, architect, structural, electrical. We also performed airflow analysis to make sure that the air moving through this across the airplane wing was going to be, within the range of the robot painting thing manufacturer's requirements. So this is that same basement, but just the composite view of 3 plans that are all stuck together, and you can see the match lines in between them. The point here is that there's a lot of stuff going on. It makes it a very, very, very complicated looking drawing. We needed to make sure that we kept our presentation nice and clean, but we didn't want to take all the time and copy all the annotations across. We didn't want to have to model everything that was already down there because we would have blown our budget doing it. So what we did is we modeled just the stuff that was important, and we linked in the backgrounds that we had provided and set those behind our model, and bam. We've got something that meets Boeing's CAD standards, at least as far as the visual inspection that they do. And we could move forward with our design. So the important thing here is that when you're working in an existing building, you don't have to model everything. You only have to model the stuff that you're going to be connecting to, the stuff that's going to be in your way, the stuff that you need to dodge, and anything else that you just really want to, I guess. You don't need to copy the annotations unless you are messing with them. You can delete them from your CAD link or from your linked file and then put them back in your Revit model. Something also that's very important is when you do this, don't use the import function for a CAD link. Use the link function. The reason is because if you import it in, you now own it, and you get to play with it in Revit, and also import in all of the different line types and text types and all the little funny blocks and whatnot. Those all come in as detail items, and it's a pain. Link it in. It's way easier. This is what one of our drawings ended up looking like as it went out the door, well, for 60% at least. We ended up getting a really nice quote back from our Boeing CAD managers. They said that the guy actually was a little bit perturbed about it because he couldn't tell the difference between what we did in CAD and what we did in Revit. We're like, oh, that's great. But,
Yeah,
not that he got mad or anything, but
that was the point.
yeah. So anyway, they look pretty clean. This is what we use to, you asked the question earlier about what kind of response have you gotten with the 3D views in your construction sheets, and we've got really good comments back from our contractors and owners. This was a huge project at Boeing, and we had owners or project managers and whatever just running around the building with just these sheets. We had one of these for the construction side and one of these things for the demo side, and we had found these things printed off full size in color, hanging up all over the project. We found that the contractor was using this stuff on a daily basis to coordinate within their own guys what they're going to be doing that day and what was going to be next. We found that our project managers really enjoyed having a 3D image that they could just throw down and say, well, this is kind of what we're doing. You see a lot of red here, that's why it's very expensive, or whatever, the pertinent topic was. Something else that we found as a huge benefit to using BIM on this project was, I don't want to slide back too far, but some of the sections that come with existing drawings and existing buildings need to be updated as you add stuff to them. So if you just add the sections that are pertinent to your project and you don't update everything else, you're kind of doing the client, you're not doing them justice to their existing building or existing set. So what we did is we imported all of the existing sections that we needed into Revit, used them as backgrounds, and then cut the sections approximately at the right spot so that the information on these sheets would automatically be updated as we changed our elements in the model. We didn't have to go back and continually trace these things or chase the changes on these CAD backgrounds. And what ended up popping out at the end looked pretty good. We're also able to speed up production by creating sections to show the stuff that was going on in complicated areas, but in ways, these sections, because it's all looking at the same model, would update automatically. So we didn't have to go chase our sections. And as we're issuing, series of submittals, it can take a lot of time to keep this stuff all up to date. So this was a huge help. We could also create 3D views of complicated areas. The purpose of this one was to demonstrate how this small piece of duct is supposed to lace through this mess here. And you can imagine trying to show that in plan or in several sections like this, it still looks like a mess. So 3D really does what it's supposed to do here. This is the construction set that we had, or the 3D image of the construction version. Well, because we did a lot of field work out there and we measured everything very accurately and we created all this model of all of the existing stuff in the basement, including structure, some of the pipe sections, all the ductwork we're going to be touching, and then went ahead and mapped or routed our ductwork against the existing structure as we modeled it. We created a very accurate model, and we got a comment back from the contractor's CAD detailer saying about 95% of the stuff that we showed on our model is going to be installed within an inch of where we intended on putting it. $3 million worth of ductwork, that ain't bad. So in summary, the benefits that we found of using Revit on this project is that we were able to meet the client's expectations and create a project that was very complex with within their budget, within their schedule. We were able to provide a design that had a lot of accuracy. We're able to coordinate between all of our subs. We're able to, what else, model stuff through very complex spaces with high degrees of confidence, and we're also able to still work with the existing drawings. Lots more. Okay, so on the bottom of our presentation, our intro to this thing, I think we talked about new technologies in addition to working in existing buildings, and this is kind of like my harsh segue into that. We used to export or outsource our CFD, computational fluid dynamics modeling,
which is just airflow analysis.
Airflow analysis, where the air is going to go. We bought a package that sits on top of, it's a part of Revit, it's an add-in, and it exports it out to another Autodesk product that models airflow for us. We got pretty good at using it. We used it to model, like I said, where the air was going to go around the wing to make sure that the client was going to get a design that would meet their requirements for their robot painting things. We got pretty proficient at using this thing, and we can quickly create a model to predict airflow in not just industrial applications, but for lots of different applications, like in multi-story atriums. How hot is it going to get at the top? Is the smoke going to get up there? What if a fire starts somewhere else? Airflow in laboratories, in classrooms, in conference or meeting spaces. If you put the diffuser out at the top and you blow air down to the floor, are you going to feel it here, or is it going to stop somewhere in the middle? We can predict that. This is an example of one thing we used the airflow analysis for. In the very beginning slide of this, you saw a picture of Olympia's brand new city hall. We were the designers on that one. It's a partially naturally ventilated building. So we wanted to make sure that when we proposed this design or helped the architect come up with their window layout, we could, we had confidence that there weren't going to be high velocities of air in any occupied areas. So you don't happen to have the desk that's sitting next to the window and the air is blowing all the papers off of your desks. That was the purpose. What you see in this thing is all the red is bad. That's the upper limit of ASHRAE's human comfort air velocity number. And all the red happens to be in areas where they're unoccupied, and we didn't, the thing that spits out the picture doesn't include the desks, but you get the idea. We can use the same piece of technology for wind loading on the side of a building to support the structural calculations. We can do siting. We can do wind pressure modeling for ASHRAE. There's a prescriptive process that you can go through to model or to verify that you have a naturally ventilated building, and that is just provide like 4% of the operable or openable area on the side of a building. Or you can model it. If you do this way, you know you get what you get. The other new technology I like to talk about is point clouds. So like I said, we did a whole bunch of tape measure modeling of the existing stuff in a bunch of different facilities. And another way of getting the same information is to employ a surveyor, and they'll go out and they'll take a point cloud. Very useful. If you want to have a really accurate model, there's no better way of doing it than getting a point cloud. We haven't found the need to do that in our applications yet, because if the duct works off by an inch, it's not that big of a deal. So if the structure's off by an inch, it could be a bigger deal. If the architecture stuff is off by an inch, it could be a bigger deal. But as far as pipes and ducts goes, I don't know. The jury's still out. And also that basement, the football field long basement stuff, took me a week to do that. A week of me going out there, whether it's about the same cost as a point cloud modeling, I don't know. By the way, when you get the point cloud back, you still have to interpret what it is. All you have is just a dot, and it represents a surface. If you have that surface and it's covered in insulation or something, you still need to know what's on the inside of that chunk of insulation. So you have a place for it, but what's actually there, I don't know. Recently, what we used a point cloud for this last project was to make sure that we knew where the duct was going to be on the 3rd floor, right below a new office build out that we're doing, so that we could tell the architect where they needed to put their chase. And we did it also so we could avoid some structure here, and that's what you're doing, but it's kind of a hybrid picture of what we did in this project. PCS, structural, awesome structural engineering firm. They happen to be upstairs from FSI. Were kind enough to loan us this picture, and they recently did a kind of a promo study to find out what new technologies are available in point cloud gathering, and they sent me a picture of this thing, and they were nice enough to let me include it in my presentation. The thing that's nice here is this picture is a lot better to look at than this picture, or than this picture, because it's got colors. From what I understand, the way that they provide the colors is they can take the point cloud to get the bits, and then they take a swath of what the room actually looks like, and it applies colors. That's great, and that can really help in speeding up that dissemination of what the actual stuff out there in the world is. So thank you so much to PCS for providing that, Rick. Great. And this is about all I've got. Do you have any questions then for Kevin or I? Wow.
Yeah, go ahead.
Yeah, please.
Suggestion for your next point cloud. You can go out there and do a visual survey and take an account of what is what and put on little reflective tags, and you could annotate everything, and then once it's in the scan, then you'd have it in the scan while you're reproducing the model.
Okay, so you've got a suggestion that if you're doing a point cloud, you can put little annotative tags. I'm reiterating for the folks at home. And the tags will have the information on what it is, so then when you scan the point cloud in the room, you've got the information right there on the pipe.
Yeah.
That's great. That's fantastic. Anybody else? Yeah,
Yes.
Rob.
Maybe talk a little bit about the as-built. You said that one project you spent a week out there as-building. Kind of I guess the value in that, because there's a point cloud, or is your as-building, I guess how you include that into your services to spend a week or whatever. Is it different using Revit as the traditional CAD methods? Did you notice any difference, or as far as time?
It's way quicker to do in Revit.
Yeah, we ended up doing some of that, the hexachrome, the one that Kevin was talking about. We did some of that in CAD and then took that back to the office and changed it into, the question was whether we're seeing an increase in speed as building or modeling existing structures or whatever in Revit versus in CAD versus point clouds. It's faster to do it in Revit.
Once you learn how to use Revit, once you learn how to use it, it's way faster. I mean, that's why we're able to take a laptop out there and just start, popping up columns. And I mean, it sounds like we spent a week out there as-building that, but if you really understood what was in that basement, you'd be very surprised that we just did that in a week. I mean, we touched, like Brandon said, $3 million worth of ductwork, which isn't even probably a quarter of that ductwork in that area that we showed there.
The building's huge.
The building's huge, but I mean, it's so much quicker. I mean, the GSA project, that's a good project. It's a public project. It's not a Boeing project. That's a private owner. But GSA, I mean, you as-built that, and I mean, that didn't take you very long at all.
Yeah. The thing that I think really speeds up using Revit versus using CAD is there are two things. I'm going from, we use 2D CAD. We don't do a lot of 3D CAD.
Yeah.
If we were as-builting in CAD, we would not only have to show what the diameter and the size of the ducts and where they start and where they finish, but we'd also have to include the height of the duct. And in Revit, you can just pick, this is going to be a 16-inch duct, and it starts approximately here in plan, and it is at 10 feet above the floor that I'm standing on, and you draw the duct, and then you say, it drops down 5 feet, and you just change your orientation, and click down, and it makes all the elbows and transitions for you. In Revit, or in AutoCAD, you got to draw all that stuff, and then you have to annotate the next size and the next height, and it takes a lot of that stuff out.
Yeah.
Revit speeds things up for that reason. The information is in the model, not in the annotations that are pointing at the picture of the model.
So just real quick, I wanted to touch. So the GSA building, how big is that building?
It's about 100,000 square feet.
And how long did it take you to do? Like
I
4 hours?
traced the background in about 4 hours, and then we did field work over 2 days. That first one was to map all of our proposed routing, probably spent about 4 hours in the field cleaning up our proposed routing, and then we spent another 4 hours verifying existing connections.
Yeah, so about 12 hours to do a 100,000 square foot building.
Yeah,
So I mean,
pretty
it's
quick.
fairly quick. Once you learn how to use it and realize that you do not need to model every last doorknob, I mean, and you can still get what you need. I think there was a question up there.
So one of the advantages of drawing in 3D is to avoid the other disciplines.
Right.
And the modeling that I've seen, especially on the existing, do you have an electrical engineer who's also designing Revit, or did you just draw the duct work to avoid the existing electrical or other items that are there and not show that on the drawing?
Yeah, a lot of this. Let me read it for a second. A lot of the value in drawing everything in 3D is being able to route around and avoid conflicts with the other disciplines. And you're saying how a lot of the stuff that we showed in our presentation is just mechanical.
That you can see.
That we can see. Did we have an electrical that was doing Revit? In any of these cases, no. We didn't have a structural who was doing Revit. We were the only sub that was working in that field. We drew our ductwork to avoid the existing electrical based on walking around in the field, knowing where the existing cable trays and whatnot were, and we just dodged them. And any place where we saw that there was going to be a conflict with what we put in and what was already out there, we basically just told the electrical, in this spot there's a piece of ductwork that's going to go right through a light or right through a junction box or a piece of conduit that you've got to deal with. So
Yeah, I mean, we didn't model every last conduit, but if it was a main rack that had a lot of conduit and runs on it, I mean, we definitely showed that as a rectangular box in our model.
Yeah.
You know,
we
But if
included
it-
a couple cable trays.
Yeah, definitely put a couple. But it was
Those are
just the
easy.
ones that we knew were going to be conflicts. I mean, a single conduit here or there, like Brandon says, is easy to say, hey, we need to move this. So, you know.
Also should be said that the purpose of what we modeled of all the existing, purpose of all this stuff was to get a construction set out. The end product back to our clients is not the BIM model. It's the stuff that's going to get installed from our construction site. They're going to end up getting CAD backgrounds back. And we'll also give them the Revit model, but they probably won't want it. or
Probably won't use it.
So.
Yeah. So we actually just got, it's in construction right now. We're actually, so all these examples you saw here that was just us doing it. I think we have a picture on one of the slides of an office building that we did down in Renton where we actually worked with Miller Hall on a...
Yeah, see if I can find it.
it's in here somewhere, but
Yeah.
yeah, so that was a project we actually got to collaborate with them on, which
Oh.
was nice because we didn't have to build the background.
That was great, yeah.
Yeah, it was, and so,
This one.
yeah, that's it right
There
there.
we go.
So roughly,
Yeah, this is the fourth story of the towers that support the ceiling in the 481 building in Renton, and all of the structure there is all existing. And Miller Holt was kind enough to model all of that stuff for us, or for the project, I should say, not just for us. And then like the green and the yellow layers there, that's brand new office space. It's about 900 feet long and 50 feet wide. And we wrapped a bunch of stuff around the existing structure and avoided all the stuff that Miller Holt wanted to put in. And we're trading our linked files back and forth. So yeah, we have a
yeah, we're
good deal
definitely
of experience
collaborating with an architect on this one, but
Yeah.
you know, it's interesting enough that a lot of the stuff we've done has been us doing it. I mean, I mean, working with Miller Hall was great. It was nice to be able to collaborate with them, but we want to do more. I'm not sure of a lot of electrical firms are using it right now, but that's just, I mean, they might be out here, but.
Do you feel like an overall pleasant success on that, all the collaboration and that?
Oh, on that
Yeah,
project
on this
there?
one,
Yeah, oh yeah.
One thing that was really useful employing Revit on this project is all of the, we're putting our VAV boxes and our mechanical equipment right on the, it's a walkable ceiling above the 4th floor. The guys who are going to be maintaining those VAV boxes and, you know, hauling new filters in and, you know, replacing stuff on whatever happens to break down the line, need to be able to roll a cart around that 5th floor, that deck level, and get to every single VAV box. So what we were able to do is show that we could, in fact, roll a cart to each one of them without getting in the way of, you know, or rolling over a piece of pipe or a piece of duct. Providing those access paths were really good. It was really necessary. And also coordinating with our architect, because part of the deal was we needed to make sure that that access path that we were providing didn't, I guess, follow a different path than the path that they were providing for us. They had some little step ladders and whatnot that they intended us to follow. So anyway.
Are we about out of time, or got time for more questions?
A couple more. We can keep, okay. We'll keep going.
Yeah.
Can you speak to that? And then when I talk to consultants, I say, well, why aren't you doing this in Revit? And I'll say, well, because these other sophisticated 3D programs are out there, Revit's not spending time on us and the key folks to really develop Revit for us.
So what you're finding is that your subs are just handing one-line drawings to the
consultants had one-line drawings to the subs,
okay.
Subcontractors
Yeah.
in general, at HVAC subcontractors. Will then
put it into Navisworks? That's what you're saying?
Which is supposed to be a better, allegedly better program for HVAC. And then worrying about all these problems with the that has become an excuse to not pursue Revit.
Yeah, I'd say that we haven't ran into that. I mean,
the last project that I was talking about, the one with the football field long design, we were working with a contractor who was doing all of their detailing in AutoCAD and not in Navisworks. And I talked to him about whether, you know, where is that, you know, that connection between Revit and Navisworks or AutoCAD MEP and Navisworks. And what they were doing is they're using AutoCAD MEP to model all of to detail everything, because that's the program that they had the key to, or I guess the license of the software to export the sheet metal to the fabricators. The Navisworks program, they didn't, for whatever reason, have the export key for that, or they weren't used to using it like that. I don't know, they like AutoCAD better. You can export from Revit to Navisworks. I have not found a way to get from a Navisworks model back to a Revit MEP model. So that backwards forwards connection. Now granted, I'm coming from the place where we were using Revit 2012. They might have gotten better with 2013, I don't know yet. But that could be the reason why it's making sure you can fab everything out of some program and making sure that you can have that cross-compatibility back and forth.
Yeah, and like Brennan said, on that project, I mean, it was $3 million worth of duct work, so I mean, and they do a lot of work around here, and so we've actually shared 2 or 3 Revit models with them.
And it was actually really useful to them for us to give them our Revit model at the different design submittals, because they could just import that into either AutoCAD MEP or into Navisworks, and they could see what, at least gives them a starting place to detail everything out. So I see it only as being a help for consultants to be working in Revit in a design build scenario, just because it speeds up the contractor and installing getting their model together. No sense in everybody drawing it twice.
Yeah. We got time for one more question up here.
Got one more? Okay.
One more?
Yeah, go for it.
When you guys were out there at building the model, you guys didn't put like the pressure on the block, and CFM, so it's you have all that information on equipment.
No, we didn't spend the time putting like the like the air handler information in. No, we don't. Yeah.
The question is, did we spend the time to input all the detailed information, airflows, the voltages, blah, blah, blah.
Yeah.
And we didn't spend that time on the stuff that was already there. We spent that time on the stuff that we were installing.
Yeah.
If it was new, if we were touching it, we had it in there so that you could click on a duct and you could find out what the static pressure needed to be to get to the air from wherever you started to there. And that worked great in a lot of cases. The tap fittings and screws that all up. So, but
yeah.
Anyway,
so
you're back to the old pen and paper.
Yeah, and on stuff like that, it's almost quicker than to go in there and try to mess with some of that stuff. So, yeah, we didn't do that.
All right. Okay, well, thanks, guys. Appreciate it. That was great. Yeah, that was a great presentation. So, yeah, if you have any little follow-up questions, they'll be hanging around afterwards. You can come on down and talk to them. So, yeah, thank you, Brandon and Kevin and FSI. Thank you to ABC Imaging. I saw they had to sneak out already, but if you want gather some information, there's some things here. I'm sure they'd be happy to talk to you. There are some lunches left, so if you didn't get enough and you still want to take some back, go for it. Our next meeting is August 15th, so I hope to see you out here. And thank you, everybody, and feel free to hang out and chat if you want. All right, thanks, everyone.